The global pursuit of knowledge, understanding, and adventure is at the heart of Discovery Quest. Olympus encourages and supports these projects, be they for archaeology, cultural heritage, forensic anthropology, geoscience, or to simply pursue ideas, dreams, and answers. As they uncovered the mysteries of the civilization at an ancient Roman villa, St. Anselm College researchers made discoveries and developed new techniques for analyzing archaeological materials. The villa is within the commune of Castelviscardo, about 15 miles from the historically rich city of Orvieto, Italy. Orvieto is home to deep subterranean tunnels and burrows, including the Pozzo di San Patrizio, a 62-meter deep well that dates back to 1537. It is also home to the strikingly beautiful Orvieto Cathedral. Dr. Mary Kate Tunes, Associate Professor of Chemistry, and Dr. David B. George, Professor and Classics Department Chair, led the St. Anselm research team. Dr. Tunes specializes in analytical chemistry with a focus on environmental science and archaeometry. Along with teaching, she has published numerous papers and has been invited to present her work at international technical meetings. Classicist Dr. George specializes in Hebrew narrative, Greek tragedy, Roman epic, and ancient philosophy. His archaeological projects are in western Crete and central Italy. Along with teaching his classes, he has published numerous papers, presented at conferences, and makes regular appearances as a scholarly expert on the History Channel's Battle BC. Professors Tunes and George and their students used our Handheld XRF to gain a better understanding of the history of Castelviscardo and the ancient peoples who lived there. The villa's significance traces as far back as the Iron Age, and it was once an Etruscan healing shrine and later a Roman bath complex. While there is much to learn at the site, archaeological research teams are rarely allowed to disturb artifacts or transport them to labs for analysis. The portability of our analyzer and its ability to almost instantly analyze several elements and metals in a material non-destructively gave them an ideal discovery tool. Of particular interest to the research team was the significance of a series of lead pipes, the development of protocols for GPS XRF metal mapping, and the structural and architectural methods of this ancient civilization. The series of lead pipes and connective keys were in close proximity to a water supply and drainage system dated between 1 BCE and 1 CE. They discovered that tin was found to be consistent for all of the keys, while levels of iron and lead showed differences both in content and homogeneity. They also determined that tin remained relatively constant for the length of the pipe, while iron and lead varied inversely to one another over the length of the pipe. These and similar discoveries supported previous theories that Roman pipes were often the product of recycled lead from other sources. The combination of portable GPS and XRF is ideal for archaeological studies. It essentially provides instant metal mapping. However, the researchers determined that a systematic approach must be taken in collecting XRF and GPS data. This ensures consistency in sampling and ultimately the integrity of the data, especially when taken by students new to excavation and data analysis techniques. The St. Anselm research team developed simple procedures involving a handheld GPS, our handheld XRF, a digital camera, and a field notebook, along with standard excavation and sampling tools. They compared ancient mortars and hydraulic cements in the exact locations where they found them. The XRF data successfully differentiated between different mortars and different hydraulic cements. The elements found to be most useful in understanding the development of the structures and architectural methods for mortar comparison of drains and trenches were iron, lead, zirconium, zinc, calcium, and rubidium. Variations of these elements in different layers of the mortars provided comparative information regarding mortars of different ages as well as of raw material sources. There were also indications from the measurements that original floors could be differentiated from floors placed on buildings at a later date, and for original mortar versus repair mortar. For more information on the St. Anselm College Archaeological Dig at Coriglia, visit their blog at www.digumbria.com. For information about other Discovery Quests sponsored by Olympus, visit our website at www.olympusndt.com.